Hey there, science fans! Welcome back to another exciting episode where we explore the wonders of science and technology. Today, we're diving into the fascinating world of nuclear power plants, a marvel of modern engineering and a cornerstone of our energy infrastructure. These incredible feats of engineering harness the power of the atom to generate electricity, providing us with clean and reliable energy. Imagine the immense power contained within the tiny nucleus of an atom. Nuclear energy comes from the nucleus of an atom, which is the central part of the atom where protons and neutrons reside. It's a tiny but mighty source of power. The energy stored in the nucleus is incredibly dense and potent. But how do we get this energy out? How do we tap into this powerful source? That's where nuclear fission comes in. Nuclear fission is a process that splits atoms, releasing enormous amounts of energy in the form of heat. It's a process that splits atoms, releasing enormous amounts of energy in the form of heat. This heat is then harnessed to produce steam. This heat is then used to produce steam, which drives turbines to generate electricity. The steam turns the turbines, and the turbines generate the electricity that powers our homes and cities. Stick around and I'll break it all down for you. We'll explore the science behind nuclear fission, the safety measures in place, and the future of nuclear energy. Now let's take a closer look at the heart of the operation, the nuclear power plant. It's like a giant, high-tech kettle. The main components are the reactor, the cooling system, and the turbines. The reactor is where the magic happens. This is where nuclear fission takes place. The cooling system keeps everything at the right temperature. It's like the plant's air conditioner. Finally, the turbines are like giant fans that spin to generate electricity. These components work together seamlessly to provide us with clean energy. So how does nuclear fission actually work? Let's dive into the fascinating world of atomic energy. Imagine a tiny atom, like uranium. This element is crucial for the process. When a neutron hits the nucleus of a uranium atom, it splits it into two smaller atoms. This is the essence of nuclear fission. This splitting releases a tremendous amount of energy in the form of heat. The heat is then used to produce steam. Think of it like a chain reaction. One split leads to another, creating a powerful sequence. One atom splits, releasing neutrons that hit other atoms, causing them to split, and so on. This creates a self-sustaining reaction. This process generates the heat that powers the entire plant. The steam produced drives turbines, generating electricity. It's a bit like a game of atomic billiards. Each collision sets off another, just like in a game of pool. But instead of hitting balls, we're splitting atoms to release energy. This energy is harnessed to power our homes and industries. Pretty cool, right? Nuclear energy is a powerful and efficient way to generate electricity, providing a significant portion of the world's energy needs. It's a marvel of modern science and engineering. Section 4. From heat to electricity, the power generation process. In this section, we will explore how the immense heat generated from nuclear fission is transformed into the electricity that powers our homes and industries. Now that we have all this heat from nuclear fission, what do we do with it? The process begins at the core of the reactor, where nuclear fission takes place, releasing a tremendous amount of energy in the form of heat. Well, we use it to make steam. This heat is transferred to water, causing it to boil and produce steam. The heat from the reactor is used to boil water, creating high-pressure steam. This steam is crucial as it holds the energy needed to drive the turbines. This steam then flows through pipes to the turbines. These pipes are designed to withstand high pressure and temperature, ensuring efficient transfer of steam. The steam spins the turbines, which are connected to generators. The turbines convert the thermal energy of the steam into mechanical energy. These generators convert the mechanical energy of the spinning turbines into electricity. The process involves electromagnetic induction, where the movement of the turbine generates an electric current. And voila, we have electricity. This electricity is then transmitted through the power grid to homes, businesses, and industries. It's like a giant tea kettle, but instead of making tea, we're making electricity. The concept is similar, but on a much larger and more complex scale. Section 5. Safety and environmental impact. A responsible approach. Of course, with great power comes great responsibility. Safety is a top priority in nuclear power plants. Multiple safety systems are in place to prevent accidents and contain any potential radiation leaks. Nuclear power plants also have a very small environmental footprint compared to other energy sources. They don't produce greenhouse gases, which contribute to climate change. By utilizing nuclear power, we can generate electricity while minimizing our impact on the planet. Section 6. Conclusion. Powering the future with nuclear energy. So there you have it, folks. Nuclear power plants are incredible feats of engineering that harness the power of the atom to provide us with clean, reliable energy. From nuclear fission to steam turbines and generators, the process is a testament to human ingenuity. Remember, safety and environmental responsibility are paramount in this field. As we look towards the future, nuclear power will undoubtedly play a vital role in meeting our growing energy needs. Stay curious, stay informed, and keep exploring the wonders of science.